Okay, now we're going to practice doing problems where we're doing images from convex mirrors. So first of all, our frame of reference is different. So when we have our principal axis, and this is our object in front of the convex mirror, if I was to make a circle, remember this is the center of curvature, radius of curvature, and I can call this C or R. And my focal length is half of that. So again, because of our frame of reference, in physics we always have to have a frame of reference, because it's on this side of the mirror, the focal length is always going to be negative. C is always going to be negative. And the distance of the image is always going to be negative. And in this type of a problem, the images are always going to be upright, virtual, and smaller than the actual object. Okay? So let's look at the first problem. So we're going to write our given and our find. So it says an object is 20 centimeters in front of a convex mirror. So that means that's the distance of the object is 20 centimeters. And it says with a negative 15 focal length. So we're given that it's negative. But a lot of times they're not going to tell you it's negative, but they're going to tell you it's a convex mirror. So you have to know to make that negative. So then it says locate the image. So that means I want to find DI. So our basic equation is 1 over F is 1 over DI plus 1 over DO. We're going to rearrange the equation to solve for the unknown in terms of the known. So DI is equal to DOF over DO minus F. So DO is going to be 20 times negative 15 divided by 20 minus 15. So 20 times 15 would be 300 divided by, now this is where people are going to make a mistake, and I already did it. It's DO minus F. So this is negative 15. So in my denominator, a negative and a negative is a positive. Okay? So you have to be very, very careful here with my sign. Okay? So when I do all that on my calculator, remember, I'm going to have 20 times negative 15, which is negative 300. And then in my denominator, 20 plus 15 is 35. Divided by 35 comes out to be negative 8.57. So DI is going to be negative, we'll say 8.6 centimeters. So the negative, DI should be negative because with a convex mirror, the focal length, the center of curvature, radius of curvature, and then the distance to the image is always going to be negative because you're always going to have a virtual image, meaning that it's going to be on this side, not this side. Because remember, we have our frame of reference. This is positive and this is negative. This is our axes. Okay, and then we always have to have a frame of reference. So that's how we do that. And as long as we remember this, this is helpful. And again, that it's always going to be upright. So that means that it's always going to be upright, the images. So that means HI is always going to be upright, which means it's going to be positive. It's going to be virtual. So that means DI is negative, which is this is virtual. And then we also know that it's going to be smaller when we look at the height of the image compared to the height of the object, which we didn't have to do in this case.